Hi, this is Pasha van Beirut. Today I'm going to show you all the basic features of MuSkeMo. So I'm going to show you how to install it, what Blender settings I recommend, and some of the basic model building features up until export. Now MuSkeMo is still in a pre-release version, so if I add features that change the behavior substantially, I will re-record this video, but I think it's going to stay the same for now. So, I'm going to assume you've installed the latest version of Blender, which currently is Blender 4.1. So I've installed Blender. I've recently found out that Blender 4.2 is going to cause some backwards compatibility issues with the add-ons. So I might have to resolve that in the future, but let's cross that bridge when we get there. Pasha from the future here. While recording the tutorial, I realized that Blender 4.0 and up has changed the OBJ exporting functionality. So you have two options. If you are using MuSkeMo version 0.5.6, then you need to use an older version of Blender, anything below 4.0. If you are instead using a newer version of MuSkeMo, everything will probably work, but you might want to use the newest version of Blender in that case. So to install the add-on, you just go to GitHub, then you press Releases, and you download the latest release, which is muskemo.zip. It already exists, but that's because I downloaded it before. To install it, you go to Blender, go to Preferences, Add-ons, click Install, and then you have to point Blender towards the zip file that you just downloaded, which in my case is called muskemo.zip, so let's find it. And that's this one, which was downloaded today. And there it is. Now it's installed. We still need to enable it. And now MuSkeMo has appeared in this tab to the right. This is MuSkeMo. It's a plugin for Blender. Now I realize that some of you might be unfamiliar with Blender and the controls, so to help you follow along with what all the keys I'm pressing, there should be a keyboard and a mouse in the bottom left of the screen, although I can't personally see it while I'm recording. However, if you're completely unfamiliar with Blender, I recommend you follow Blender Guru's donut tutorial, at least the first couple of videos, because he really does a good job of explaining all of the basic controls and navigation in Blender. I build all of my musculoskeletal models for OpenSim and for Scone, although MuSkeMo is essentially simulator agnostic, sorry. It's just a tool that allows you to translate 3D scan data to biomechanical data. However, if you want to build OpenSim models, or your main goal is to perform simulations in OpenSim, then it's actually advisable to use their axis definitions. And as you can see, Blender by default actually prefers Z is up, whereas OpenSim and I think the International Society of Biomechanics as well usually use Y is up. And the way that the basic controls in Blender are set up, it makes it very challenging to actually construct a model using the Y-axis as the up direction. So to change this, I recommend you go to Preferences, Navigation, and you turn the orbit method to trackball. This stops Blender from locking the Z direction as the up direction. And you'll also want to select orbit around selection. At least I prefer this. What this does is that if we, for instance, select this cube, the default cube that always appears when you open a new file, well, now the camera will orbit around the cube. If we move the cube by pressing G and then moving it anywhere we want, the camera will now orbit around the cube. You still might want to move the camera around physically by pressing Shift and middle mouse button. But in general, these are the settings that I think are beneficial, or most advisable, I should say. Now, enough of that. You'll want to delete the default cube, and then we can start importing our relevant files. Today I won't be building a full model. I'm just going to show you all of the basic features, but it's still advisable just to save your file before you start. I'm going to save it under a folder that I created specifically for today's tutorial. And then we save. So the first step, of course, is to import the files that you want to use to build your model. So we do this under import. Now I'll be importing both an STL and several OBJs. I'm just going to import skin outlines generated via convex hulls, but this is just an example. MuSkeMo will allow you to generate these convex hulls automatically in the future. The button's already there, but I haven't added the scripts yet. So for now, I'll just assume you have 3D meshes available, for instance, from CT scans. So we have here EMU skin outlines generated through convex hulls, and I'm going to import some bones. These are OBJs, so we go to import and then wavefront.obj. And I'm going to select, I don't want everything, I just want a pelvis, a thigh, a pelvis, a thigh, a shank, toes, and right metatarsals. Import. Oh, actually, this immediately gives us some possible weird Blender behavior. Blender tends to transform your models when you import them. And by this I mean Blender rotates your models when you import them unless you change this setting. I don't know why this is the default behavior, but it is. So you'll want to set the forward axis to Y and the up axis to Z, and then it doesn't transform your models during import. But because I forgot to do this, oh no, I'd apparently not forgotten to do this for the skeleton. Sorry, for the skin outlines. And now they're nicely aligned, and as you can see, the y-axis is up, so that's exactly what we need. One thing to think about, let's first organize everything. If you press right-click, you can add a new collection. A collection is just a folder in which you keep things. I'm just going to call this bones for now. And I'll move everything in there, and the skin outlines can stay. Let's make another collection. Let's call this tissue outlines, tissue outlines. Now there are some things that are important to Blender, or that are maybe idiosyncratic to Blender, that if you're unfamiliar with might cause issues. If you import things and they were automatically rotated, then and you have the model selected under the transform panel, which is under item and then transform, the model might have a rotation like this. And if you can't necessarily tell that it has this rotation unless you select the specific model right? Because if I select something else, then there's nothing here. But if I select that model, I'll see that it has a rotation. Now, we don't want it to have a rotation, and in this case, the model is also incorrectly aligned. So we could just press 0, and then there's no rotation. But let's assume that the model is not aligned in the way that you want it. Well, then, for this case, I'll just apply the rotation. So now the model has no rotations, but it is not aligned in the way that I want it to be aligned. That means we have to perform a transformation. And in Blender, the controls are relatively simple. G for grab, this translates. R for rotate, this rotates. And S for scale, this obviously scales. But especially with the rotate command, we are now rotating about the viewport, and that's not what we want. We want to rotate about specific axes. So in this case, I want to rotate about the x-axis. So I press R, and then I type in 90 degrees. Sorry, I press R, then press X to say that I want to rotate about the x-axis, and then we press 90 degrees. But that rotates it in the incorrect direction. So, backspace, minus 90 degrees. And there we are. Now the model is correctly aligned again. And let's say we're not done. If I want to rotate about the local y-axis, I can do the same by pressing R. And if I press Y, I first am rotating about the global y-axis. If I press Y again, I am now rotating about the object's local y-axis. So this is true for any command in Blender. If you press one of the axes once, you transform about the global axis. If you press the axis again, you transform about the local axis. So we have transformed it back, and the rotation is not applied. So Blender stores transformations as the object's data, but if we want, if we're happy with the orientation and the transformation of the model, we should apply these, because these will otherwise affect otherwise affect all the calculations down the line. So I'm going to apply these. In this case, just the rotation, and now you can see it disappears. We're still not done. We're going to pre-process this further, because all I want is a pelvis section, a femur, a shank, metatarsals, and toes. So I'm going to press Tab to go into edit mode, press P, and then separate this by loose parts. And now I get all of these separate skin outlines that I don't want. So I simply select these. And we press delete. Can remove this floating arm as well. And this femur. So now we are ready to build our model. So now we can go into MuSkeMo and start looking at the features. So MuSkeMo lives in these panels. We have an inertial properties panel. This is to compute inertial properties from 3D meshes. So that's what we're going to be doing first. Then we have a body panel. This is where you can define your rigid bodies that eventually go into your model. We have a muscle panel. Once you have defined rigid bodies, you can parent muscle points to those bodies. You need to define bodies before you can define muscles. We have a joint panel, an export panel where you can export all of the data that you've created, an anatomical and local reference frames panel. I'm not going to be dealing with this today. We have a landmark and marker panel and a contact sphere panel. If you want this to be wider, which I think is easier to work with, all you have to do is drag this panel out. So let's start by defining some inertial properties. So I'm going to select, there are several ways to do this actually. We're just going to use these this top function because currently the convex hulling functions haven't been added yet. In the way that you can compute rigid body parameters is by assigning a density and then either selecting one or several of your meshes or pointing MuSkeMo towards the correct collection. So I'm just going to show all the features. Let's say I want the pelvis to have a density of 1000, which is just the default, the density of water. I select it, then press compute for selected meshes. And then it looks like nothing has happened. But if we go to this, if you press on the object properties, which is this yellow square over here, and then scroll all the way down to custom properties, you will see all of this new data. MuSkeMo has now computed the mass, the inertial tensor. It shows you what density you used, and it gives you the center of mass of the object. So this is X, Y, and Z. And so Z, it's perfectly symmetrical. That's why this is 0. And the X, Z, and the Y, Z components are 0. Again, showing you that it's a perfectly symmetrical body. Now this is one way to do it. The other way to do it is to select several objects. Then doing the same thing, let's say we want these to have a slightly higher density, 1200. Okay, compute for selected meshes. And now all of these have custom properties as well. There's, again, another way to do this. Let's say we want everything in a collection that we defined here to have the same tissue properties. Well, that's easy. Then we just give them a single density, type in the collection name where they're placed. In this case, it's tissue outlines, but I'm going to purposefully make a spelling error. And then we go compute for all meshes in collection. And now it tells me that this collection doesn't exist, and that's because I made a spelling error. And if we press it again, now all of them have rigid body parameters. I've assumed that everything is simply has the density of water. Now it's also important to realize that these parameters are not dynamic. I can't, if I want to change the center of mass of this hull, so of the pelvis hull, if I want to change the center of mass, I can change it here, but then the model won't shift its position. So during export, it will use the changed rigid body parameters, but you won't see it. So this is not advisable to do it this way because you'll have to remember that you manually change these parameters. So the best way to change this, if you actually accidentally make a change, you can just select it, recompute it, and then it flips back. If I want the center of mass to move forward in the X direction by 10 centimeters, then what I would do is select it, press GX to move it forward, and then you can type in 0.1. Then it moves forward, and then you recompute it. And then you can see that it has correctly changed the center of mass. Now I'm going to undo this. So now we have rigid body parameters for these meshes, but of course we want to have bodies, not meshes. So to do this, we go to the body panel. And here you have to start typing in your bodies manually. So we have a pelvis body. I type it in and then I press create body. And now it has created a new body, and then because the object properties panel was still open, we can see that all of these new data custom properties have been defined. It doesn't have a center of mass yet because this is a massless body for now. It has no attached geometry. It does have a MuSkeMo type, which is body, and you shouldn't change this. This is just so the plugin knows what you have created. It has no inertia yet. It doesn't have a local frame assigned, and it has no mass. Now, if I want to assign so what I actually want to do, another thing is that what happened is that when you create your first body, it creates the body in a new collection that is named here. If I change this now, the next body will be added to a new collection, but of course, in general, I'll want all of the bodies to remain in the same collection. Now, my pelvis body has no inertial properties, but what I can do is select the skin outline for which I've pre-computed the rigid body parameters, and then press Assign Pre-computed Inertial Properties. Now, let me undo this and change the view somewhat. Hold on. Because you can't, otherwise you can't see what happens. So we have the pelvis body, which is this, which are these axes, and because it has no rigid body parameters yet, it is assigned to the origin. And once I select the pelvis skin outline and I press Assign Pre-computed Inertial Properties, it shifts to the center of mass location that it actually has. So that is behavior that I prefer. So that's what MuSkeMo has. The center of mass is visualized in its actual location. Because the inertial properties were computed with respect to the global axis system, the center of mass will always be aligned with the global reference system. So it does not make sense to rotate these axes. So bodies, at least currently, bodies do not have an orientation in MuSkeMo. They can have an orientation with respect to local reference frames, but that functionality has not been implemented yet. It will be added in version 0.6 of MuSkeMo. We're currently at 0.5.6. We have now added a rigid body parameter. That is one way to add this. There are several ways to do this, actually. We can add the body parameters without first pre-computing the rigid body parameters. So let's say I have this thigh outline, and I know that I'm going to be using a density of 1000 anyway. So I'm just going to pretend that I haven't pre-computed its rigid body parameters. If I were to create a thigh R body, it is now added to the origin. If I know that I'm going to simply use... Oh no, wait, let's first try and using the same button again. That is, Assign Pre-computed Inertial Properties. If I press this, we'll get an error because the source object doesn't have pre-computed inertial properties. Instead, we can compute them right away by selecting the body, the target body, which is the thigh R, and by selecting the skin outline, and then by pressing Compute Inertial Properties. So we will get an error, but it's not an error, it's actually a warning. It tells you that the source object, the thigh skin outline, did not have a pre-computed density, and in that case, MuSkeMo assumes a density of 1000. So two things now actually happen, because we see that the body has shifted. So the body now has inertial properties, but we can also see that the thigh skin outline also has inertial properties. So I deleted these, but it has essentially just recomputed them. So there's two ways to assign rigid bodies. I'm going to make this slightly wider because I just realized that some of the text is getting cut off. So let's now create a shank body. Create new body. This body does not have inertial properties yet, so we select the shank for which we have assigned for which we've pre-computed the inertial properties. And now we have a shank body. Let's do the same for the metatarsals. I'm just going to call MTR. And select, create the new body, which is, so you can select them in the viewport, but you can also select them here. And sometimes that's easier if it's not visible. And then we select the skin outline that corresponds to it. We press assign pre-computed inertial properties. You can also just press compute inertial properties, but realize, no, that will work because the skin outlines already have a pre-computed density. Now there's one other interesting feature what you can do for the toes. I'm just going to call these toes R. Create new body. In certain cases, you will want a body to have multiple. You will want to combine several meshes into one rigid body, and that's possible. So you can just select them all by shift-clicking them. The toes body is selected. And then we press assign pre-computed inertial properties. And then you can see that we get a, hold on, let me double check something. No, it gives the same result. So it uses, if they don't have pre-computed inertial properties, it will first compute them. And then if you have multiple bodies selected, it applies the parallel axes theorem to give you inertial properties, and it calculates the combined center of mass of the different bodies. So we can double check this by comparing the skin outline center of mass to the toes center of mass, and we can see that they're not the same. So these are the different ways to assign rigid body parameters to newly created bodies. There's one more thing that's worth pointing out. So let's say I want to change the rigid body parameters manually. For instance, I want to, this only works for the center of mass, but it's still worth showing. Let's say I want to change where the object center of mass is. Well, that's possible. I can, of course, just change it here. Let's say I want to move it sideways by 1 centimeter. So math works in Blender, so we can just go 0.01. And now we see that actually the axes didn't change, and that's because these, again, are not dynamic. So if you manually change the center of mass, then you can press Update Display Location using center of mass. And then you see that it has shifted. Let's undo what we did here by reassigning pre-computed inertial properties. So bodies can also have display geometry, which we imported, except I forgot to import the pelvis. So for now, the pelvis won't get display geometry. I'm going to turn off the tissue outlines now visually, and then turn off the X-ray so everything's a bit easier to see. This is the body. This is the thigh body, and I would like to assign visual geometry to the thigh body. So there's a simple button for this. That also lives in the body panel, and then you have to open this sub panel. And all you essentially have to do is select the target body, select the geometry that you like, and then you press Attach Visual Bone Geometry. Once you do this, the bones will get moved to a new collection called the geometry collection. And this will also be the name of the folder that everything gets exported to, that all the visual geometry gets exported to. So if you would like this to be more descriptive, you can, for instance, change this to emu geometry or whatever you like. Now we can press attach visual bone geometry, and then we get an error message, and this is important. If we read this, it says none of the selected objects is the target body. The target body and body name, which is the input at the top, must correspond to prevent ambiguity. Operation cancelled. So what does this error message mean? Well, it means that the body that we selected here, which is the thigh R body, which we can read here, is not the same as the body name input here. Now, I've added this error message because for now, I don't think it's possible to dynamically update this name based on the selection state in the viewport. If this changes, I can, of course, remove this error message, but for now, this error message will have to remain because otherwise, there's the potential that you make an error in which body you think you are applying an operation to. So we want to apply this to the thigh R. So we have to again type in thigh R here. Then we can select them both, press attach visual bone geometry, and it has now been attached. And we also get a warning at the bottom, which has now disappeared, that shows you that the emu geometry collection didn't exist yet. So that has now been added. And now if we were to move this body around by pressing G, for instance, we see that the body has attached visual geometry. So that's great. We can just go through this with all of the bodies that we've created. So let's do this for the shank. And now I'm going to make a mistake. I'm going to select two bodies and the shank, press attach visual bone geometry, and then we get an error message that tells you that you've selected multiple bodies. So we don't want to do this. So attach visual bone geometry. Same for this body. This is MTR, I believe. So we go through this, attach visual bone geometry. And we do this for the toes R as well. Attach visual bone geometry. Okay. Once these bones get moved to emu geometry, they also get a MuSkeMo type attached. We can make this wider if you want to be able to read it fully. You can see that it has the MuSkeMo type geometry. It also tells you not to modify this, and it tells you what body it's attached to. And if we go to toes R, we also see that toes R now has this geometry attached. It's possible to attach multiple bodies to the same, multiple visual geometry files to the same body. We can do this, for instance, for the skin outlines. Let's say you also want to attach these. Well, then we select this, select the toes R, and we press attach visual bone geometry. And if we move the body around now, we see that both the tissue outline and the bones are attached to the toe R body. But for now, I think I don't want this. And if I want to undo this, you can also see, by the way, that this adds the attached to custom property and the MuSkeMo type. It's now become geometry, but I can detach it from the body. You select the geometry file and the body and then press detach a visual bone geometry, and then it detaches it. So now I can move it around again, and the tissue outline is no longer attached to the toes body. What it did do though is move this to the emu geometry folder. So if we don't want this, then we have to move it back to the correct collection. And now we're back where we were. There's another thing that's worth realizing. The way that we attach geometry in Blender is by using the Blender function called parenting. And if you have an older version of Blender, actually no, it still does this. If you have an older version of Blender, it adds, excuse me, it used to add whatever parented geometry you have to a specific body, it moves it to that collection visually. And then you have to press the filter, the object filter, and then deselect object children, and then it stays in its own geometry. Sorry, then it visually stays in its own folder, even though you've parented to a different body. But in Blender 4, this behavior has changed, so then you might as well leave it on, because you can see that the bone geometry is still in the correct folder. But if you're using an older version of Blender, you should go to Object Children and turn this off. Okay, so now we have bodies, and in principle we could already export what we have. We could export the tissue, the inertial properties that we computed for the tissue outlines, which I'm not going to do now, but that's possible. So if all you want to do is compute rigid body parameters for your meshes, then all you had to do was go through the first step, and then you can go to the exporting panel. But I want to first add some more data. So let's add some joints. And in MuSkeMo, this happens, of course, in the joint panel, and the behavior is quite similar to the body panel. So I want a hip R joint. And we just press create new joint, and the joint has been created. And we immediately realize that this is not a very nice visualization radius. So I could have changed this for the bodies as well, but I didn't. But for the joints, this is going to bother me. This is too big. It has a radius of 5 centimeters. So I'm going to delete this, and instead first change the visualization radius. So everything is in meters in MuSkeMo, because that's the default unit in Blender as well, and it's just convenient to keep everything the same. So let's change this to 1.5 centimeters. Create new joint, hip R, and there we go. Joints are initially placed at the world origin, so there it is. And for the joint, we're going to want to align it to whatever body section we want to align it to. So let's first introduce two extra hotkeys in Blender. On your number pad, if you want to if you want to zoom in on what you have selected, let's say I want to zoom in on that, I press period, and then it zooms in on there. If I want to view this from the side, I press 1. Sorry, if I want to view this, I see that the hotkeys appear to have changed, but okay, if I want to view this from the side, I press 7. If I want to view this from the front, I press 3. If I want to view this from the bottom, I press 1. You can also just press the axes if you like. So if I want to view this from the side, I can also press the Z axis, but I like using the number keys. And what we're actually interested in is the hip. So let's go to the hip. I press 1, zoomed in, I can slightly zoom out. And I want to first view this from the front, because I want to align this with the hip with the head of the femur. So now I press G for grab, and I move it here. And if we orbit around it by pressing middle mouse button, we see that it's not perfectly aligned. So one thing we can do is press Y, and then we're perfectly aligned. Or if we want to do this in perspective view, we can press G and then X to make sure we only translate around the X-axis. And there we go. that's good enough for now. This gives me a hip R joint. So let's, and now once joint is created, we can of course assign parent bodies. So the hip will be, the hip's parent body will be the pelvis joint. So will be the pelvis body. So let's select the pelvis and again the hip joint, and we just press assign parent body. Now if the pelvis moves, so does the hip. And we can assign a child body, and the child body for the hip will of course be the thigh body. But let's say we accidentally select the thigh body geometry, right, the bone visual geometry, and go assign child body. Then we get an error message because what we have selected is the visual geometry. And the bones are just for visualizations. Those aren't the bodies. So we get an error message an error message that tells you what you have done incorrectly. Okay, let's try again. Hip R, select the correct body, which is the thigh R body, assign child body, and now the thigh is assigned as the child of the hip. So if we move the hip joint, the entire thigh will move, and if we move the pelvis joint, both the pelvis and the thigh body will move. And also we can of course rotate the hip joint. For instance, if we press R, Z for local rotation, and then we can see, then we're looking at something that looks an awful lot like hip rotation. In MuSkeMo, I have added some joint utilities, such as reflecting a right side joint, and you can do fitting of joints. Fitting of geometric primitives. You can fit spheres, cylinders, ellipsoids, and planes. I'm not going to go through them in this tutorial because there's some additional functionality that I'd like to add. But the basic idea is, I'm going to quickly copy over something here. The basic idea is that you select whatever geometry you like. So let's first duplicate this, then select this out. Let's say we're interested in matching it to these condyles. What you would then do is select those condyles. I'm going to do it very roughly because this is just for visualization, for demonstration purposes. We're going to select these condyles, select the inverse, that didn't work, sorry. Select invert, delete everything else. There we go. And then we could, if we would like to, fit a cylinder to the selected body, and then we have a cylinder here that is fitted through the bone geometry that we had selected. Now I'm not going to use this, but you could if you wanted to. So I'm going to delete all these things that I just created. Let's remove the cylinder fit. Let's remove this duplicated visual geometry. Okay, let's create a knee joint. So again, we have to press knee R, create new joint. It's created at the origin. I move it to wherever I would like. So let's just move it here. Move it here. And we have to assign a parent body again. So I've selected the thigh R, select the knee R, assign parent body. Let's close this because it's a bit busy otherwise. So now the knee R has a parent body. And now let's assign a child body. So I press Shift, and actually I've accidentally selected two bodies. So let's see what happens. Whoops. It tells you that you've selected too many bodies. So let's deselect that one, assign child body, and now the knee has a child body. There we go. Perfect. We can go through this again. Ankle R, create new joint. Move the ankle to approximately here. Now I'm not going to create a perfect model for now. This is just to visualize, this is just to demonstrate how everything works. Okay. Go R. Assign parent body, assign child body. And let's say I accidentally assigned it to the incorrect body. First of all, when a joint is created, that's interesting. I can't find where the joint actually is. Did it get assigned somewhere else? So now we actually are getting this weird visual setting that I talked about. So I'm going to turn off object children, and now the ankle has reappeared. So if you were following along visually, you will have seen that the ankle had actually disappeared in the joint centers collection. And I'm not completely sure why it suddenly changes its behavior, because it didn't for all of the previous joints. But yeah, once that happens, you press this button, turn off the object children filter, and you should be done. So once you create a new joint, it gets all of these custom properties. It gets a type, it gets a child body and a parent body, which initially are unassigned. You can, I've pre-allocated these parent and child frame orientations and locations, but those are for now unused. That will also be added to MuSkeMo version 0.6. And you can, if you want, fill in coordinate names. I'm going to go through this in a bit. Let's check if I've made any errors. So the hip has a child body and a pelvis body. The knee has a child body and a parent body. There we go. The location and the rotation that will get exported by MuSkeMo are simply the location and rotation, at least in global coordinates, of the joint itself. Which you can find in the transform panel if you press item and then transform. So for instance, the knee joint is at this location and has no rotation. For now, I recommend you actually don't rotate joints, but in the future you will be able to. I think that will also be version 0.6, but that does complicate model coordinate definitions somewhat. Now there's one more joint we need to add, and that is a MTP joint, metatarsophalangeal joint. Let's add this MTP, create new joint. MTP is here. Let's assign the metatarsals as the parent body. Let's assign the toes body as the child body. And let's say I'm not happy with what body I've assigned it to. Oh, I made an error. Oh, this is good, actually, because that way I can demonstrate what I've done wrong. I forgot to first move the joint to the correct location. And now I've parented the bodies. And if I move it, I move the parented bodies somewhere else. That's not what we want. So, to undo this, we have to have the joint selected, press clear child body, press clear parent body, and then move the joint to the desired location. We move it here approximately. Now, if you build an actual model, you will of course want to take more care. You want to be more careful about where you place the joints, but this is just for for demonstration purposes. Again, we assign the parent body and assign the child body, and then we're done. So now we have a more or less rudimentary model. We have a model that has a hip joint, a knee joint, it has an ankle joint, and an MTP joint. So in principle, again, you could export this. If you are interested only in doing an inverse dynamics analysis without any muscles, you could be done now. But let's add at least a few muscles. So this, of course, happens in the muscle panel. The basic idea is, again, the same. We define a muscle name. Let's call this iliotibialis cranialis. Now, I'll have somewhat of a problem because I didn't import pelvis visual geometry. So I'm going to do this now just to make this tutorial slightly more easy to follow. Let's add the pelvis hat, import. Now we have pelvis visual geometry. Let's move it to the bones collection. So just to rehash how that works, we select the pelvis body, we select the visual geometry we want, and in the under the attach geometry subpanel, we press attach visual geometry, and we get the error message that the incorrect body is typed in here. So we press pelvis, attach visual bone geometry, and I made a spelling error. And there we go. Now it's attached. So now I want to create a muscle. So in the muscles panel, I want to create iliotibialis cranialis, and let's say it's the right side. Now I'm using my own personal preference where I just add an underscore and then a small r or L to denote the side of, for instance, a body, a muscle, or a joint, or anything. In the future, you'll be able to add custom delimiters, so it can be capitalized. But for now, I would recommend you follow this convention because that will allow you to use my built-in mirroring scripts. So if I want to add a muscle points are added to the 3D cursor location. And the 3D cursor in Blender is this thing here. If we select this, if you press this button, the 3D cursor will follow your mouse clicks. But I tend to prefer a different way to use it. I tend to go just press this version. Select the regular select box, and instead move the 3D cursor around by pressing Shift and then right click. And then it gets added to whatever, wherever your mouse is. So this is now where the 3D cursor is. And if I'm happy with iliotibialis cranialis being here, or maybe I should add it here, then we press Add Muscle Point. And now I've done something that actually is problematic because it already has a muscle point added, but I have no body selected. And I'm going to add error messages, but currently this error message doesn't exist yet. And what actually has happened is that you've added a muscle point without selecting the target body as well. And that will give a problem because that means that the muscle isn't parented to anything. So I'm going to delete this muscle. And the way that this is going to work, or is supposed to work, is that you select the parent body, then you press Shift right mouse button so you add the 3D cursor location to where you want it. And then you press add muscle point. Now I'm going to add another muscle point because I want it to be slightly more complex. So I'm going to add it to here for now. Add another muscle point to the pelvis. Then I'm going to add one to the femur here. So I have to select the thigh body, deselect the pelvis body, and then add muscle point. And now if you look closely, you will see that we have added a muscle, and it is very hard to see because this point is not actually where we want it. It was a placeholder point, and we can move these points around. So if we select a muscle and press tab, we go into what's called edit mode. And if we then select that point, we can move this point around in 3D space. So I want this to be somewhere over here. Maybe slightly back, so I press GX. Okay, and this point actually is also going to be a placeholder point because I want the final insertion to be on the shank. So let's select the shank, add the 3D cursor to where we want it, and we go add muscle point. Now we have an insertion, and we'll want to move this further. So let's move this here. Now this might not be the best way. Actually, I'm going to move this point down as well. There we go, GX. So now we have a muscle, and if we have a muscle, we can rotate the joint, and then you see what we want to see, namely that the muscle, the first 2 points are parented to the pelvis, and the second and the third point move with the thigh, with the entire thigh. And if we only rotate the knee, then we see that only the last point is attached to the shank. So you can do this for all the muscles. There's one feature you can I should also demonstrate. Let's say I want to add a muscle point between the second and the third point. I want to add this to the thigh. So then I can use the insert muscle point command. So we have 1, 2, 3, 4 points, and if I want to add it after the second point, well then I first again select the 3D cursor to approximately where I want it. If you want to predefine it, sorry, let me first show you how it works. So then I do press insert after 2, insert muscle point, and now we have a muscle point over there. Sorry. Then if we want to move this point again, press tab, select the correct point, GXX, and there it is. Now this isn't going to be a very pretty or accurate muscle, but it does demonstrate the concept. If you don't like that you're essentially adding placeholder points and then moving them around, you can also press again shift right click for the 3D cursor location, and then under view you can change the location of the 3D cursor like this. But it's actually moving quite quickly. Let's move it to, let's say I want to move it forward by 10 centimeters, then we go 0.1, etc. So this is also an option. The rotations of the 3D cursor are ignored, of course, for the muscle points. I'm not going to add more muscles than this. Of course, if you want this model to actually work, you should add more muscles. I'm quickly going to demonstrate the contacts panel. And this is just for the contacts panel is only to define sphere locations for now. So the way that it works is you create a contact sphere, again using the 3D cursor location. So now we can actually see something that I was talking about earlier. The view isn't actually orbiting around what I would like it to orbit around. So one way to somewhat fix this is now by selecting it, and that's why I prefer orbit around selection. But I'd also like to center this, so I press the period on the number pad, and then it's centered around my view. Contacts, again, these live in the contact panel, are defined around, are assigned to the 3D cursor location, similar to muscle points. And this is quite easy. You just select it, press contact sphere. And there it is. Because currently I'm only exporting locations, this visualization radius doesn't actually matter. So if you think it's too big, you can press S and then scale it down. I think in the future I might actually export the user defined radii as well, but because this is so particular, to simulator, different simulators, I don't know if that's actually useful to do within MuSkeMo, because simulations don't happen within MuSkeMo. This is how you add contacts. Now these contacts immediately get added to their own collection, but they don't have a parent body yet. So in this case, I'd like to assign it to the toes body. So I select the correct body, select the contact, and press assign parent body. They don't have a location in a parent frame yet. This will all be computed during export in the upcoming version of MuSkeMo. Now the landmark panel essentially has the same behavior as the contact panel, but landmarks do have a visualization radius, and it initially says it's 0, but that's not true. It's actually at 1 millimeter. Landmarks get immediately parented to whatever mesh you select. So if I want to parent it to this mesh, we select the mesh, shift right click, create landmark, and now we have a landmark that is added over there. Okay. Landmarks only have a type, and their location is essentially just the global location. There is an anatomical and local reference frames panel, but I'm going to add this to the new, I'm going to go through those functionalities once I add them to the new version of MuSkeMo. So I'm going to skip that for now and just go to the exporting panel. So if we want to export our data types, we can essentially export all the data types that we have defined in MuSkeMo. So we can export bodies, joints, muscles, mesh inertial properties if you only computed the inertial properties of your tissue outlines. We can export the reference frames, which I'll skip for now, landmarks, contact locations, and a visual geometry folder. Now this is essentially, the behavior of all these is the same. So I'm not going to go over this for all of them, but let's say I want to export my bodies. I'll press export bodies, and it's essentially as simple as that. It immediately opens the folder location in which you started, where you have saved your blend file. If I want it to be somewhere else, I simply select a new folder and press give it a name, for instance, emu demo model, and then all of my data will get exported to this folder unless I change it. Now, as you can see here, it immediately selects your export as a CSV file. So if we export it, we now have, sorry, that's the incorrect folder. We have a CSV file. Ooh, I opened it in Excel, which I don't want to do. Let's open it with Notepad++. And we now have a CSV file which has all of the data that we assigned. So the pelvis has a body, a center of mass in global coordinates, moment of inertia in global coordinates, and whatever visual geometry we attached. As you can see, it's a CSV file, so the delimiter is simply a comma, and if you attach multiple geometry to a body, the delimiter will be a I actually don't know what the English word for this is, but this is the character in English. However, let's say you don't want it to be a CSV file. Well, that's possible as well. Then you go to Export Options and change the file type to, for instance, TXT or whatever other text-based file type you would like. And you can even change the delimiter if we want it to be, let's say we want it to be an underscore, which I don't, no, let's not use an underscore. Let's use 2 commas. This is all possible. Then we go to bodies, export bodies, bodies v2. Let's add it to the same folder that we just did. And now it's a text file. So let's open this and we see that the delimiter has changed, and of course the file type is also changed. So you can export it as any file, text-based file type you like. I'm going to turn this back into CSV, turn this into a comma. If I want to predefine where we want the model to be exported to, we go select export directory, and then you can select the directory or create a new one. So we select emu demo model, select model export directory, then select, and then it will automatically, well, it will still ask you if you want it here, but it will pre-select the export location to here. So we can export the muscles if we like, change the name if you want, export muscles. And we have muscles here, and here you see that it adds a new row for each muscle point. The first point is automatically called the origin, the last point is automatically called the insertion, everything else is a via point. It adds the parent body name, and it adds the position in global coordinates. I'm going to add, again, local coordinates in the new version of MuSkeMo. The final, all of the other export functions are the same, except the export visual geometry folder. And this behavior is actually changed with the newest version of Blender. So I'm going to have to update its behavior and make sure it's compatible with the newest version of Blender before I demonstrate it. So for now, if you want to export visual geometry, you have to use an older version of Blender or wait until the newest update. And I think that will be the end of this tutorial. So some of the functions are still a bit, some of the functions still haven't been added, so you have to bear with me. I'm adding them essentially weekly. And if you run into any bugs, please either email me or you can submit an issue on the GitHub. If you submit an issue, please be specific in what you tried, and it can actually be helpful to include your entire blend file with me. There's one final thing I think I'll actually show before I conclude this tutorial, and that is a Blender built-in functionality. So sometimes Blender will crash. That is just true for every program. Now, I found Blender to be quite stable, but sometimes if you try to undo certain functions or certain things, then Blender can crash. And if that happens, there's no need to worry, because if you reopen Blender and go to recover and then autosave, you will see that there's usually a very recent version of whatever file that you've been working in. So for instance, in this case, There's a 2-minute older version than the version I'm working in. Okay, that will be the end of this tutorial. So thanks a lot for following along if you've made it this far.